This is Chapter 2, Introduction to C Programming. Objectives in this will write simple computer programs in C, use simple input and output, use fundamental data types, learn computer memory concepts, use arithmetic operators, learn the precedence of the operators, and write simple decision-making statements. Now, this just shows you a first program in C. They do have a /n here. That is if you want to do a write hello world. Then next line, you want to write hope you have a great day. Now, if I run this, let's see what happens. Notice that it's all on one line. If you want having them in two separate printf statements does not mean that they'll be on separate lines. Some programming languages are that way. In C, you put a /n for a new line, and so that'll go down to the next line. So then if I run that, you'll see they're on separate lines. Now you're not limited just to having one. You can put as many as you want. So if you want to do two new lines, you do /n/n. And you see it goes down two lines. There's other control sequences that we'll take a look at for that. Now, you can put comments in your program, and that's you can also use a slash, asterisk, and then whatever, and then asterisk slash, where everything in between is a comment. I think you can put two slashes. This is a comment. And so when I run it, you see it works just like before. What a comment does is allows you to put your documentation in here. So maybe I would want to author who wrote the program, the date, 06/03/2020, and purpose. This program prints hello world. Now, you can put the slashes on each individual line like that, or like the indicate here, you can do the slash asterisk to do multiple lines. And then asterisk slash down here. And now everything in between those is a comment. It means the program ignores it, strictly for documentation purposes. It makes the .c file bigger, not by much, so I don't think it's like consuming a lot of memory or anything. When you go to run it, it doesn't make your program running any slower. The compiler ignores any comments and doesn't put them into the executable, because the executable wouldn't need any comments anyway. And you see again, if I run it, it works just like normal. Now we saw this already. The pound include and then stdio.h, standard input output, and this is called a preprocessor directive, and it allows us to have access to that code. And the printf that we are using, that prints something to our screen. That's output. We're going to see a little bit later on in this PowerPoint that we can bring data in. Okay, lines beginning with pound are processed by the preprocessor before compilation. Line 3 tells the preprocessor to include contents of standard input-output header in the program. The header contains information used by the compiler when compiling calls standard input-output library functions such as printf. So it gives you a lot of functions you can run. Blank lines, you can have blank lines. You can have white space. Doesn't matter. You try to have some kind of style to your programming. You would not have varying like this. It lets you do it, but it's considered bad programming. See, it works just fine. I ran that. Works just fine. Whatever style you develop, you just be consistent about it. If you want to have that many spaces on there, you could. You could have 3 spaces. So like that. Different books get rigid about that. They say, well, this has to be 3 spaces or has to be 4 spaces. Some of them indicate that it should be whatever a tab is. So if I were right here and did tab, that takes me out to 4 spaces. Now the tab probably makes more sense than anything, because then if you're over here, you just simply do a tab instead of 1, 2, 3 spaces over. But that's up to you. Oops. You can do whatever you want in that regard. Let's see. White space characters are normally ignored by the compiler. This is not necessarily true with every package. It's true with C, so I can do a tab, and you can see I run it. And I run it just fine. I took a COBOL class at Fort Scott Community College when I first started going to programming, and it wasn't very much of a class. He didn't want to be there, and he just had us type in programs out of the book and compile them and run them. No changes at all. Just type in what you see and then run it. And he told everybody in the class to do a tab to go over like that. I don't know why, but I was doing spaces. I don't know why I wouldn't hit the tab. I was doing spaces. Nobody's programs in the class worked, except for mine. When you do a tab, if I can get there, if you do a tab, that puts a special ASCII character there. ASCII table. This is a good website for programmers. ASCIItable.com. And horizontal tab is this character right here. And then space, where's space? Probably looking right at it.
You can use Control F to find it a little easier.
No, this is an image. But yeah, that would be a good idea.
Oh, is it number 5 down in there at the bottom right?
Bottom right. Number 5? I don't know. But the space is actually got its own character. Oh, here, space. So it's this one here. And so even though it's invisible, it's actually there. I think in Word, like if I'm right here and I do an enter, that's a paragraph mark. Right here, and I do a shift enter, then that's a new line. And I don't think I can see those, except for this right here. But there's a way to search and replace those. Let's see if I can copy that. And I should know where replace is. Find replace there. And so paragraph mark, it puts a slash or caret P there versus a line return. Carriage return. Where's it at? Manual line break. That must be it. Which is caret L. So what I'm saying basically is that you may have something that looks like a space, but it's actually one of these characters. So if you're working with a package where you're doing tabs or you're doing some kind of special characters like that, and it's giving you a weird error and you can't figure it out, do a backspace and just simply do your spaces there to see if that fixes it. I've had a couple of programming languages that's worked on. Most of your popular ones now, you can just do your tabs and be fine. Okay, this talks about the main function. I didn't put an int here when I created this morning, so I'm going to put an int there and run that. And process return 0. The format of this is this is what's returned. So we're calling this this function in different programming languages. That's called different things: procedures, subroutines, methods. But this is a function, and it's going to return a value. This int, the int stands for an integer. An integer is a number with no decimals, like 5, 7, 0. This indicates we're not passing anything in. Void in programming means, in case of a function, means nothing's returned or it means nothing's passed in. So when I run it, and you see that it returns 0, then that indicates something. I'll talk more about this in a minute, but 3 divided by 0 %d slash n a. Now notice it did not return 0 anymore. It returned this weird number here. That would indicate to us that it didn't work correctly. It actually had a division by 0. So this int is a code that you could check to see if it worked okay. You might say, well, I can look at the screen and see if it worked okay. Well, the idea is you write a C program that you then put out maybe on your Linux box, and it's run from a shell script. And the shell script is going to run the C program, and it's going to return a value. Well, then you can check that value to see if it worked or not. It's called a function. Okay. C programs contain one or more functions, one of which must be main. The main is what it decides to run. Every program in C begins executing the function main. The keyword int returns an integer. We'll talk about that. We'll talk more about it in chapter 5. The void in parentheses here means main does not receive any information. I indicated that. These are other controls you can use, escape sequences. So if I do a /n, that's new line. /t is a horizontal tab. This is if you're trying to line things up on the screen. And this will seem real backwards to you if you're not used to this type of programming. Because if you've used C#, then you can write things out nicely on the screen, formatted and so forth. If you use Word and Excel, you know you can format things. And this is assuming you have a text-based setup. For example, you're running a C program on a Linux box that does not have the GUI, the X windows. If you've ever used Ubuntu or Fedora, it looks like Windows. It's nice GUI. You click here and so forth. For servers, servers typically do not have that interface. They do not have that GUI, that graphical user interface. GUI stands for graphical user interface. They have just a console based, so it looks something like this. And you have to do like dir, do cd, dot, dir, all this. Let's see. Go to Hayes, make directory test2, change directory to test2, dir test.txt. And for the life of me, I don't remember in DOS how to display a file. I keep wanting to do what I do in Linux. It's like cat test.txt, and that doesn't work. But anyway, this shows you the interface you have. Now, a lot of servers do not have that graphical interface for a reason. It opens up potential security risks. Anytime you have a GUI, then that opens up more ports and more areas where you can be hacked into. So the simplest server you can design without the graphical user interface, without the operating system, is the most secure one. That is why Linux boxes, they don't crash as much, they don't get hacked into as much, in theory. A Windows server, if you're hosting your website on a Windows servers tend to get hacked into more. I've been hacked into twice on my Windows. I have a website that's hosted on a Windows server. I chose it for a specific reason so I could run ASP.NET programs on it. I could run the Windows part, and I also have some Linux ones. And Linux never been hacked into, as far as I know, but the Windows has. And again, when you have that GUI, it just it's a security problem. They actually thought at Network Solutions that the reason why I was hacked into for that particular instance was because I had my ASP.NET program up there. They thought that the hackers used that to get in and create a directory and do all the things they did. I don't know if that's true or not. I think they just had poor security. But again, so if you got just a text-based system like this, then returning a value so you can check to see if it worked is essential. So the horizontal tab is if you want things to look good. So if I had printf sales /t year /t and amount /n, and printf 3,000 in sales /t year 2020 /t, and then the amount of 1,500 /n. Now, obviously, I need to put a line break after this is out to 4 spaces. So let's do that. Slash in. See how there's tab stops there, and it's lined up in nicely in columns. Now you do this mainly when we get to looping. So if you're using what's called a for loop and a while loop, where you loop through like 100 items, and you want them all to be lined up perfectly, that's where you use that. You wouldn't hard code values like this.
So C can be used for databases then.
Yes, it can. Not your maybe the some of the Windows based ones you'd see, but probably more of a ones you'd run on Linux. Um, year of sales. Okay, so if I run this now, you notice the year of sales it was so long that it went over to the next tab stop. So it's 1500. We're either going to have to do one or two more tab stops. I'm guessing one more. Um, so slash in and run it. And did I go over? Slash in. What am I doing? Slash T for horizontal tab stop. There we go. And that lines up. We'll see later on how you can pad spaces on the end, so you can always ensure that you have the right amount of spaces before you do the tab stop. But sometimes you have to play with it in that manner. Now you might say, well, why do I need to worry about that? You do it one time and you're good. Well, yeah, I'm hard coding 15 or I'm hard coding 3,000 here. What happens if my sales increases to that amount? And like you said, Kyle, you're pulling it from a database. Then all of a sudden, it's screwed up and it's scooted over. And I think there's a whole chapter actually on formatting that we'll see. Slash A is an alert, produces a sound or visible alert without changing the current cursor position. So if I did a slash A here, you couldn't hear it on your end because I haven't shared my system audio, but it just did a little bell of some sort.
The error beep.
No, it's a pleasant one. I wonder if I could stop sharing and then share it with audio. Let me see. Stop sharing and share with share computer sound. Okay. Let me run that again. You'll be able to hear it this time. Actually, I'm not even sure if I've heard that sound very much on my computer.
That's the install when you go to install something new. That's the computer sound where it's like, "Are you sure you want this program to make changes?"
Oh, it is. Okay. Yeah, I get the error quite a bit, so I know it's not the error one. So that's interesting. Now the slash slash is a backslash, because if you want to put a backslash in there by default, it assumes that you're putting some kind of control in there, escape sequence. So if you actually want a backslash in there, you have to do that. If you want a double quote, by default, if you put a double quote, it assumes you're ending this. Notice how this begins with a double quote and this ends with a double quote. I know both of you have had quite a bit of programming already, but for somebody who hasn't had programming, this is called a string. String contains alphanumeric characters. You can have numbers, letters, special characters. It begins with a double quote and ends with a double quote. If I try to put a double quote here in the middle, because I want it to print, it'll think I'm ending the string. So if you do want it there, you have to have your slash double quote. Let's see. Standard library functions like printf and scanf are not part of the C programming language. Um, and there's a reason for that. Because you might think, well, wouldn't you want those? Printf prints to the screen, scanf brings in data. It seems like that should be an integral part of the system, but the idea is only bring in what you need for the program, and that way it keeps your program small. If I bring everything in under the sun, then my program will be so huge it'll take up a lot of memory. It'll just be overkill. Um, you go. My brother and me went hiking out in Colorado when I got out of high school, and of course, we didn't know what we were doing, and we wanted to eat well. We went down to the store and so forth. We looked at the dry food and thought, we don't want to do that. We're gonna take cans of food, because we want to eat well. We want to make chili, over a campfire, while we're hiking and so forth. So we bought all these cans of food. We bought just numerous junk. Um, and when we got there, we thought, well, we want to do it like the old days. We don't want to go on no trail, so we started going straight up the mountain. Um, we thought we were gonna die. Um, there's trails there for a reason, and we obviously weren't in good enough shape not to go on those trails. And so once we found a trail, we stayed on it. But those cans of food were overwhelming. That's the same idea. As we took too much with us. You just want to take the very bare amount. If we had took the very bare amount, our backpacks would have been light. Um, Same with programs. You don't want to bring everything in. You just want to bring in just what you need for that. Okay. And it says, for example, a compiler cannot find a spelling error in printf or scanf. That's actually an error you'll get. If I'm over here, printf, hello again. And I run that. Didn't work. Because this is uppercase P, this is lowercase p. C is case sensitive. Now, nice part about code blocks is you'll see it over here. See the little red indicating you got an error. That tells you got something wrong on that line or the line before it. Sometimes it's a little tricky in that regard. You come down here. This is actually the error message you'd see if you were compiling this on Linux using GCC. And you'd have to figure out what in the world that's referring to. Now, it says line 18 right here. So if you got an editor on Linux where you can bring it in, you can see line numbers, that'll help you a lot. And then it tells you undefined reference to printf. It's like, what in the world does that mean? Sometimes the error messages are pretty obvious. Sometimes there's no clue what that's indicating. And I can't make that bigger, I guess. If I change that to little p, let me get rid of this. Sometimes it'll tell you the correct line. Sometimes it'll tell you the next line. I don't know what this one will do. We'll see. Notice here, it's telling me I have an error on this line. And I can look at that line all day long, and it's perfect. There's nothing wrong there. What's wrong is that up here, there should have been a semicolon. And this one actually gives you an error message where you could tell that. It says expected semicolon before printf. But it still told you the wrong line number here. Now, very popular is people will delete that or not put it. And comes up here, goes that line, and it says expected declaration or statement at the end of the input. And it's like, what in the world does that mean? That error message doesn't help us at all. It's beneficial in your programming if you line up your curly braces. So if I have this in the first column, I put this in the first column. That's a visual for me to look to see if those line up. But even better than that, if you click here in code blocks, it will highlight this with the same color so you can see which one it matches with. Now, you do not have that capability on a Linux machine if you're using GCC, the standard editor. I suppose if you have some program you downloaded for Linux, CodeBlocks might be on Linux, I don't know, then you might have that capability. But if you're working with a text-based format, you don't typically have that. Okay. The compiler compiles a printf statement, merely provides space in the object program for a call to the library function, but the compiler does not know where the library functions are. The linker does. When the linker runs, it locates the library functions and serves proper calls as library functions object program. Basic idea is when you compile it, it brings it all together. So it locates that library, brings it in, and when it's all said and done, when I run this, let's see, temp C project. C project. Bin, debug. When it's all said and done, we have an exe. And so if I double click this, how do I open it? I fully expected the window to pop up and go away, but I'm not seeing it. It gets this. There is a way to run that in Windows, I'm sure, but it's an executable we can run. Now, unfortunately, when you run it from this interface here, I ran it from a command prompt so I could see it, but if I ran it from here, it would run it and then immediately exit off. You'd have to put a scanf at the end for you to see the results. But anyway, it creates an executable. It's all brought in now. This I could email to you. I'd have to zip it up because systems don't usually like you to email exes. But I had to zip it up and send it to you, and then you could unzip it and you could run this program on your computer. Okay, I'm gonna grab a drink. And like I say, it's called an executable. Print. We showed that. /ins. You can put them anywhere. You don't have to put them at the end of the string. Now the next part is a scanf. Scanf allows us to bring in data from the user. So this is a program to add two numbers together. So let's create that. int number 1, int number 2. What this does is this declares something called a variable. A variable is a way for your program to remember something. Computers are the stupidest things ever. They can never remember anything. They have to store it off somewhere. And that's kind of the same with a human. When we remember something, we're storing it off in a brain cell. Somehow, it's a mystery how it works. But if you ask me my son's birthday, I can tell you what my son's birthday is. Maybe I have 1,000 facts that I got memorized. That's up in my brain. Probably a lot more than that. But I wonder how many you would have memorized. Those are all stored in your memory, in your brain cells. Somehow, if you need to retrieve something, you can easily retrieve it. It's just a brilliant how that's the design is on that. Well, unfortunately, we don't have that brilliant design in programming, so we have to give it very crude names. Number 1, number 2. You can call this whatever you want. There are restrictions to it. You cannot have spaces. Like I cannot have a space. That'll give me an error. You cannot start it with a number. That would give me an error. And I'm curious what that purple means. Um, unless it just is an issue. Okay, so it tells me that's a problem. Tells me that's a problem. Can't start it with a number for whatever reason. And it tells me this is a problem. You can't have weird symbols in like that. Now, if you do want spaces, then like if I want sales for 2020, that's going to be my variable. I'd really like it to be a little bit more readable. I'd like it to look like this. What is allowed in a variable name is underscores. And see, there's no errors. This makes it look a little bit more readable than putting it all together. Some people prefer this. I use both. That's kind of whatever you decide. Some places you go to work at are very stringent on naming. Something that's like Coke Industries, KOCH, they had like you had to start some of the variable names WS. You had to start some of them WA, and those indicated something. Like it's been too long, but WS might have indicated that it's a temporary variable that I'm only going to use this one time and not use down in later in my program. Maybe WA meant it's throughout my entire program, all of my program. Now, IFR did not have any restrictions on variable names. I probably wish they did. I got burnt really bad one time by using a reserved word. I don't remember what I used. I don't know if some is a reserved word. But I used a reserved word and took me forever to figure out my error. I spent probably a day or two figuring out what I was doing wrong because I could not figure it out. And so at that point in time, anything that might even resemble a reserved word, I put the word the in front of it. The sum, the sales. I didn't do it on every variable, but I did it on enough where you see my programs would have thes all throughout just because I got burned so bad on that. First time I had lunch is probably a year after I'd left IFR. I had lunch with my old boss, and she says, I've been making changes to your program, and she says, you're a pretty good programmer. Your code's well done and so forth. But she says it drives me crazy that you put the in front of so many variable names. So they didn't have a convention. Probably did after I left. They came up with the David Hayes rule where you couldn't use the. Okay. Now what this does is it sets aside memory space. So when this runs, the computer sets aside this part of your RAM. That's what I'm talking about when I'm talking about memory. It sets aside this part of RAM, saying this is where number one's going to be stored. This is where number two is going to be stored. And so anytime I refer to number one and number two down here in my program, it'll know where to go look for it in memory, in RAM. Now, RAM anymore is not such a huge issue. Used to be, and if you go into programming where you're programming a device that doesn't have much memory and you're using C, then you want to make sure you don't declare variables unnecessarily because they take up RAM. And I think my computer here probably has 16 gigabyte of RAM. I'm very sloppy at my programming. I declare variables and I never use and I never remove them. that becomes an issue when you're developing for a device that does not have that memory. For example, when I go to the restroom down at the Wellington Center, put my hand underneath the sensor, the water automatically starts. I'm guessing that sensor does not need 16 gigabyte of RAM, so it does not have the same memory requirements. And so if I was programming for it, I might have to reuse variables. I might have to give back memory, depending upon the language. Okay. Integer, I don't know what it is. Let's see. Integer. Integer. Range C. Not sure which one C has, but it either goes from negative 32,768 to 32,767, or this one. Which means if I set this equal to 50,000, let's see. I'll talk more about this printf here in a minute. See if that works. Okay, that worked. So I'm guessing it must be this upper end here. You can't have commas. Okay, so let's add another number on the front there. It did not print that number. This exceeds the limits of what an integer can have. So if you're writing a program that's going to exceed this, what is this? 2 billion, 147,480,647. So if your sales are possibly going to go up to 4 billion, Coke Industries that makes billions of dollars, a year. If you choose an integer, it could potentially eventually become so big that it gives you an error. These are things you have to think about when you're writing a program. Now, when we're at this level and we're just learning basic programming, I won't mention it again, but you go out in the real world, you have to consider those things. Some of these other ones. This one's bigger. It looks like unsigned integer goes up to 4 million. If I use short, that doesn't go up very much at all. So if I did short. Now all these I believe are integers. Number 1 is equal to 50,000. Again, gives us a weird result. Doesn't give us 50,000. Now you might say, well, why don't you just use the biggest one then? If you know you potentially could have an issue, just goes to the largest. The idea is, on my Windows, I have 16 gigabyte. I don't care. I'll use the biggest one. But these take up more memory, more space in RAM. And so by using a short that's 2 bytes, then this that's 4 bytes, I can save RAM. You might say, well, how much are you saving?
An insignificant amount until you get 2 million of them running at the same time.
Exactly. If you got an array, which we haven't talked about, but array may be, let's say you have 2 million items in your array. I think that's in the zeros. You take this times the 2 million times 4 bytes. So times 4. Where's my commas? Then all of a sudden you got 8 million bytes. And again, I can be sloppy in my programming because I have 16 gigabyte here. I never have worked at a place where I wrote C programs where I had to consider the memory. But if you do, then those are important considerations. Okay. I'm gonna go back to integer. Oh, by the way, you notice when I type that in, pops up with these. Um, different ones you can choose. Different programming languages, you can specify different sizes on them. And I don't know if this one's really a size here. It says C++, so it might be a C++ consideration. But some programming languages allow you to specify 64 int, and that's a bigger number you can put in there. Okay. Now our goal is we're going to get these two numbers from the user. And that's what this scanf is about. Okay, so let me shut my phone off. There. So int sum, because I'm going to add numbers together. And I did go down to the next line, and I want to get the first integer. So you need to prompt them. So printf input first number, colon. Now this will stay on that line. Now the scanf is kind of strange. It has this %d. So %d. And then I do this ampersand, the and symbol, and number 1. Now this is a telling us what type of format that we're bringing in. And the %d stands for integer. Specifically, d stands for decimal integer, which seems backwards because integer means you don't have decimals, but that's referred to as decimal integer. And to reference the memory location, you have to put the and symbol there. And then that will read in the data and store it directly where the memory's at in RAM. So then I'll do a printf input second number and scanf %d number 2. Okay, so that's going to bring in number 1 and number 2, store them in the memory location. Now here I'll say sum is equal to number 1 plus number 2. Now notice that I'm ending each one of these lines with semicolon. That'll pretty well always be true in programming, C, except for a couple times like the if, the for, and the while. You don't want semicolons at the end of those lines. The semicolon ends that statement. This is referred to as not equals, not an equation. This equals here is referred to as an assignment. Now what that means is it'll look on the right side here. It'll say, okay, number 1. And it'll look up here and it'll say, okay, where's that stored at? And this says, okay, this is stored in this memory location in RAM. It'll go and retrieve it. Let's say it retrieves 3. It'll replace this with 3. It'll go out and say, okay, where's number 2 at? And this says, okay, this is in this memory location. And let's say it's retrieves 4. So that retrieves 4 and puts 4 here. So then it's got 3 plus 4, which is 7, and then assigns it to sum, which is in a different location in RAM. Now, these are not random positions in RAM. When you run a program in Windows, Windows gives you a spot of the memory. It doesn't give you the entire RAM. It says, okay, you can have this amount of RAM to work with. And the idea on that is you don't have a program that sits there and crashes your operating system. You got your own protected space in RAM that you can use however you want. And then in theory, when it gets done running, it gives the memory back. It says, hey, Windows, I'm done with this RAM. And then RAM says, oh, okay, great. I'll give that to somebody else that's running. Now, after we calculated this, we want to print out the result. So I'm going to do a printf And the sum is, and then I'll do a %d here, /n, and then comma sum. Again, this is a format specifier. Tells us what are we working with? Working with a decimal integer again. And where this %d is, it'll take the value of sum and it'll replace the %d with it. So if I bring in 3 and 4, which is 7, it'll take the value of sum and plug it in where the %d is. And then the /n goes the next line. Okay, so if I run that, if I put 3 in here, 4 in here, it says the sum is 7. Questions on any of that so far? Okay. I use this because I can actually remember it. But I'm gonna program this. This is a physics formula. Force is equal to mass times acceleration. Now, when you're looking at this, you may not know what these stood for. So instead of using that, you can use more meaningful variable names. You don't have to name it F, M, and A. Bad programming is where you don't properly use good variable names. Maybe where you put the in front of everything. But instead of F, I'm going to declare it as force. Now, if you got multiple integers, you can do a comma and declare them all on the same line. You don't have to have them on separate lines like that. Now, you don't want to get too wordy. You don't want like a whole sentence for your variable name. This is the acceleration that's used in physics to figure the force and also to figure other physics formulas. That's too long of a variable name. And there's some kind of limit too, but you'd have to go pretty lengthy to exceed it. But there's no doubt what these are now. So you're not sitting there wondering, well, what's force stand for? What's force? What's mass? It's mass. What's acceleration? Acceleration. Good programming means you use proper names and it self-documents. You don't have to put documentation. Okay, so here I'm going to say input force. And I'll change this to force. And here I'll say input acceleration. And I'll bring in acceleration. And then down here, that's a plus. Multiplication is asterisk in programming. So I'm going to say force is equal to mass times, that's the asterisk, acceleration. Now, I started typing that, ACC, and that popped up. I did a tab for code completion, so I didn't have to completely type out the variable name. That's nice in programming. And I'll change this to the force is %d, and then I'll pass in force. And I'll run that. And I'll put in 5, 4, that should give me 20. Ah, 160. What did I do wrong? Oh, okay. I'm calculating force. Bad programming. Gave us a result though, didn't it? I want to import mass. So I get for staying up too late. 5, 4. There's 20. Yeah, I was watching a video of them destroying Quick Trip up in Wichita at 21st and Arkansas, if I'm saying that street name right. My wife made fun of me because I said it wrong this morning. So it was just it was a fascinating video while watching it. So I wasn't doing anything productive. Okay. We talked about all those. Talked about the memory. Talked about asterisk indicates multiplication. Percent sign indicates a remainder operator. Here's actually the different ones. Plus for addition, minus for subtraction, asterisk for multiplication, the divide, and then the remainder. Remainder is where you would be taking like 8 divided by 3. 3 goes into 8 2 times. Let me choose a different one. 5. 8 divided by 5. That goes, if I did that division, 8 divided by 5 is 1 with a remainder of 3. So when you do 8 divided by 5 and they're integers, that's going to give you 1. It won't give you decimals. If you do 8, and that's what this remainder is right here, the percent 5, that's going to give you 3. So if you're doing some kind of calculation and you need to find a remainder, then use the percent. If you're just doing a straight integer division, then use a slash. But that's the difference between those two. If you're into math, you can use that to figure things out. You can tell if something's even. For example, if I have 6 divided by 2, that's going to give me 3 with a remainder of 0. If your remainder is 0 when you're dividing by 2, then that's even. If you have 7 divided by 2, that's going to give me 3 with a remainder of 1. If you got a remainder of 1, that means it's odd. And we're going to look at that here shortly. I'll actually program to tell if something's even or odd. Because within this PowerPoint is also the if statement. Now, and this talks about down here in terms of the order of operations. If you remember your order of operations from algebra, it's kind of the same principle as that. Please excuse my dear Aunt Sally. Please do what's inside the parentheses. They don't have an exponent on here, but multiplication and division you do next, and then remainder comes after that. That, of course, remainder isn't in from algebra. And then Aunt Sally, addition, subtraction, and then the assignment is evaluated last. If you don't remember the proper order of operations when you're doing programming, simply put parentheses around what you want it to do first. And I do that sometimes because I don't want to think too much about the order of operations. And so if I got something complex, so I'll just put parentheses, and that really tells it to do what's inside of parentheses first. Like this right here. This will add these two numbers first because it's inside of parentheses, and then it'll multiply it times the a. And okay. Now here's your what order does it do it for equalities? We don't do anything really that complex with order matters, but this tells you what these represent. If you're trying to do an equals, in C you do equals equals. That's a real programming challenge, is people don't remember to put the equals equals. The not equal is exclamation equal. Greater than is greater than, less than is less than, greater than equal to is greater than with an equals to the side, less than or equal to is less than with an equal to the side. And these are used in if statements.
And for loops and while loops.
Exactly. So here's an example. If num1 is equal to num2, then you print that they're equal to each other. Now, I'm going to write a program so we can see the usage of the if statement. Oh, by the way, one of the projects I'm going to assign today is I want you to pick a physics formula and program it. And I'm going to specifically tell you to only use integers. I'm gonna talk about how to do a double, but we don't really see in the PowerPoint where they focus on that until coming chapters, unfortunately. Okay, so this is going to determine if a number is even. Let's see. I need to get the number in first, so let me do int num1 printf welcome to my program that determines if a number is even. /n printf input to number. I've had people in past courses where they didn't put any kind of header at the top at all to tell what the program did. So when you ran it, you're sitting there and they jump directly to the scanf, and it's just sitting there with a flashing cursor, and you're sitting there. Is it hung up? Is it in a loop? Always when you write a program, you should prompt the user to what to do, so they're not sitting there wondering. And I'll take points off for that. If you write a program where you don't put any printf at the top and it's just you start with a scanf, and I'm sitting there looking at that flashing cursor, I'm looking at it from a user standpoint. Okay, so scanf, and it's a %d for a decimal integer. And then I need my ampersand, num1. Popular programming mistake is people forget to put the ampersand on there. Now, I want to check to see if the remainder is 0. If it's 0, it's even. So I'm going to do an if statement. Now, what goes inside of your parentheses is called a Boolean. It's a Boolean check. You can think of it that way. Boolean check says, okay, is this true or is this false? So if I say num1 %2 equals 0. So this will, the percent, remember, gets the remainder. And then this is checking to see if that remainder that this returns is equal to 0. If it is, that means it's even. So I'm going to do a printf. Then I could write the numbers even, but I could do a %d is even. And then put in my num1. Now what this will do is this is our specifier, and it'll say, okay, I'm expecting a decimal integer here. It'll come over here in this first decimal integer that follows the comma. It'll take that and plug that in where the %d is. If I run that, okay, put in number 8, it says 8 is even. Well, that doesn't mean anything. Key is if I put in an odd number, it still tells me it's even. Comes back, doesn't tell me anything. So I could put an if statement down here. We're going to see there's something called an else eventually. %2 is equal to 1. Now, let's see what happens if I don't put spaces there. Printf %d is odd. And num1. Okay, so if I put 7 in here, it tells me 7's odd. So it worked just fine. I will put spaces in there so it's a little bit more pleasing to the eye and easier to read. These are programming conventions that I'm not going to dictate to you. But you have to figure out something such that you can look at your program and easily see what's happening with it. And some of you have heard this story, but I repeat it for every class. I had a student one semester, I think it was C++, and she was also a very sharp lady. She was taking differential equations, making an A in it, very sharp, and so forth. And all of her programming looked horrible. She would like this right here. she'd have there, she'd have, this over like this, this. She'd have like different things like this. Oops. That was how our program looked. And I told her, I said that you need to decide upon a style of programming and make it consistent. I said, you don't have to do what I'm showing in class, but you have to come up with stuff. She never listened to me. She never would develop that. She didn't. She wasn't successful. Having a structured, and they call it a structured programming language for a reason. Not only the programming structures that make it easier to program with, but also with the structure of the program itself. Having some kind of structured format just makes it so much easier to figure out what's going on. Okay. They just got two if statements there. Notice that they have curly braces here. The curly braces are not necessary if you have one line of code like I have here. They don't hurt anything. Like that. And like this. If you have two or more lines of code inside here, then you have to have the curly braces. If you have one line of code, you do not need the curly braces, as I indicated. You notice the format here where they put the beginning curly brace at the end of the if statement. This is very popular. You'll see this in books. I can't stand it. I like them to be lined up perfectly. So if I'm trying to see the matching curly brace, I do not have to look at the end of these lines to figure out where in the world it is. I can look at this one, I can look straight up above it, and I can see where it's at. Again, it doesn't matter so much in code blocks because when you click this, it makes them both the same color so you can see it, even if it was up here. See, when I click that, it matches that up. Not all programming environments are like that, though. So that's up to you. If you want to do like the book does, that's fine. If you want to do it the right way, then you can do it my way. I wouldn't take any points off either way. This just shows you comparing two numbers. If it's less than, greater than, less than or equal to, greater than equal to. Now here's all the keywords. These are the ones you shouldn't use for variable names. You do not want to name a variable if. So you don't come up here and declare. I knew something was off there, but I couldn't tell. There. If. Hopefully it gives you an error, which this one does. Not all programming languages do give you that. So oftentimes if I think I'm going to choose a variable name that's a reserved word, keyword, then I'll put a the in front of it, like some. Some is oftentimes a keyword. So I'd put a the in front of it. I think in C it's not a keyword. Don't worry about what all these do. We're going to eventually learn that. Now I mentioned I was going to talk about doubles. You can use, instead of int, you can use double. Now double is a number with decimals. So for example, if I want to add, I'll do force equals mass times acceleration again. So force, mass, and acceleration. Hopefully I can remember how to do this. Let's see, printf, input, force, input mass. Don't screw it up again. And then scanf, and I think it's %lf. I may have to Google that. That's the part I don't remember. And then for ampersand force, printf input acceleration, scanf %lf, and acceleration. And then force is equal to mass times acceleration. And printf, the mass is, now instead of %d, we're going to do %f. We'll talk more about that in a minute after I verify whether it works or not. Okay, 3.12, 4.5. And masses, okay, LF. I don't think it's F. Yeah. Oh, mass. Force. Okay, still not right. LF, LF. Unless I'm confusing programming languages, which I do occasionally, and it should be not double, but should be float. Let's try that. Not right. Okay. Let me Google it. My best friend. C programming. Format specifiers for double. Let's see. %d is signed integer. %f is floating values. LF is double. Well, I think I had an LF. Yeah, got an LF. Ampersands are there. Printf %f. I think I'd never programmed before. Mass. 3.1, 4.2, still not right. What else I got wrong? Okay, mass, acceleration, mass times acceleration force. Okay, let's first verify whether mass is correct. So %f / n mass. Okay, so that's not coming in correct. That's where my issue is there. Printing it, %f, print float value. Okay, my %f is correct, which must mean my scanf is wrong. Yeah, %f. Okay, C programming, double scanf. Not found. Let's see. Printf with examples. Double. Okay, and then I print it with a percent. It says LF, but you can print it with a percent %F also. Percent C. Okay. Boy, that's bad. Why am I drawing such a blank on scanf? Percent F or G? Let's see. Percent F. Let's try that one. 3.1. There it is. Why in the world was I thinking LF? I'm not sure where that LF came from. Probably another programming language. Although I'm not teaching another programming language this summer. Okay, that looks better. Now you got an issue here though. We'll talk about this later on in the course. 3.1 times 4.2 should be 13.02. Look what it came up with, 13.019999. Things you have to take into account when you're working with floating point is that you have that happen. You have issues with the rounding. It has to do with the storage and the circuitry and so forth. But we'll talk more about that later on. They had a famous problem in a chip where they were having issues like that. Anybody remember that? Maybe that's too long ago.
I think I read something about it last month, but I cannot remember.
Yeah, it was giving people like the wrong results in Excel when they'd multiply the numbers together. Rounding, floating point, problem. Yeah, there was some kind of chip they released. There it is. New floating point math and subtraction for Intel Core. Type the file into an Excel spreadsheet. I'm just curious. Okay, I get this. If I allow decimal places to be shown. Not that I'm smart enough to do that. To show decimal places. Okay. There's 3 significances that are in error, way too many for rounding. I get a true rounding error using Google.
I'm wondering if you have a different component.
Could be. What is that supposed to even give you? 0.001 times 1,000 should give you 1. And so then, instead of it giving you 1, like Excel, my computer's correct. See how it's giving us 1 even when I go out to many decimal places? But that particular Intel chip would give you the wrong result. So anyway, just something to keep in mind. You might say, well, yeah, but look how far out it is. Maybe if I went out further, I'd see it. Let's see. Ah, it is wrong. Now, for the most part, you don't have to worry about that. But if you were programming a scientific application where you're dealing with very small or maybe very big numbers, depending upon which way it goes, I'd have to really think about that. That could cause you issues. They have a data structures class usually that talks about other ways you can handle working with these problems. But looks like I have that same issue here because definitely that should, if you did it by hand, this when you subtract it should give you 0.001, and then you multiply it times 1,000. Multiply by 1,000 means you move your decimal place 3 places to the right, which should give you 1. Not this. Anyway, probably more information you want to know about that. Two projects I'm going to put out there. First one, pick a physics formula and program it, only using integers. Your choice. So you go out, Google it, and probably your easiest way to Google it, it's up to you, but is you type scite.edu, physics, formula, and PDF. And that'll give you PDF sheets. And otherwise, it brings up lots of different things. But I want you to program something on here. Your choice. You don't have to know what these represent. I don't know what this P equals W over T is, but you could choose that if you want. P is equal to M times V, M momentum, V velocity. I'm just guessing. I don't know what P is. You don't need to. You just learn how to program, put those into your program. Now, if you choose one of these more complex ones, like G is equal to GM over R squared, you'd want to put parentheses around the top or bottom if it's got more than a single variable there, just to be on the safe side. On this one, you would not have to.
Sorry, David. Did you want us to get user input on that, or do you just want us to hard code numbers?
Get user input. And you can choose. You can work with integers if you want. Now that I figured out how to do float, I'll forget it by next time. I'll try to put LF again. But you can bring in a float, which is a number with decimals if you want. And how you print it is with a %F too. Now the second thing is I want you to bring in sales and tax rate. And these should be not integers, so they should be doubles. And calculate the tax. Now the formula for the tax rate is equal to your tax is equal to sales times the tax rate, like that. And then if the tax is greater than 10, then print some message, your choice. That's just using the if statement that we looked at and combined with the printf. So those are the two projects out of this chapter. Questions on any of that?
So when you want us to use the doubles, was that where you were showing us with the floats? It's like the similar or
Right. Except for I
okay.
don't think you have to have this as float. Let me see it.
Can you do a double or
You should be able to. This well now it
okay?
probably won't work,
Of course.
but I know how to put it back. Ah, so it has to be float. I am mixing that up with another language. Or I think I tried double and LF before, and that didn't work. So okay, so back to float then. Yeah, so use floats, not doubles,
Okay.
and that should work if you use this as your example.
Okay. Um, and if we have any like programming questions, I know like I think I saw in your intro video that you were gonna have uh like troubleshoot times. Are you still planning on doing that this summer?
Yeah, and I'm just gonna troubleshoot those at the end of class. I won't always go an hour and a half.
Okay.
So
Got you.
after each class, once I finish the lecture, any questions you have, programming and so forth, we'll bring up and troubleshoot.
Okay.
And
Well, thanks, David.
if you ever can't be there for a class and you still want to troubleshoot, email me the code, and I'll still troubleshoot it at the end because it's beneficial for everybody to see it.
Right.
So,
Okay. Well, you have a good weekend.
yeah, you too.